On this week's episode, we're speaking with Benedict Evans. Benedict, of course, is well known for his popular weekly newsletter on the most important happenings in tech. If you aren't a subscriber yet, I strongly recommend you sign up at ben-evans.com. He's also famous for his big annual presentations digging into macro and strategic trends in the tech industry. This year's was titled The Great Unbundling. These days, Benedict is an independent analyst, having formerly been a partner at the VC firm Andreessen Horowitz. He's one of the world-leading experts in mobile, media, and technology trends. He's a voice of reason, trying to sort out the technology issues of the day. Welcome to the show, Benedict. We're so happy to have you here with us.
Thank you.
So, I spent last night watching several videos of yours and going through your presentations and essays. And I must say, I'm just stunned by the amount of information you're able to somehow gather, process, and synthesize.
I don't know. I mean, I think there's sort of infinite questions or infinite things that are interesting that one can try and understand. The challenge in technology is always, how do you have to let go of the things you already understand and look for the things you don't understand. I was a mobile analyst and I was a smartphone analyst. Smartphones are boring. No, they happened. Like, where they won. Apple and Google won. Everyone has a smartphone. Now what? Next question. That's some ways that might be machine learning. It might be crypto, which we haven't talked about and don't really have time to talk about now. There's all sorts of other things that are going on. In many senses, there's almost kind of a divergence because people in tech are thinking a lot about games and VR and crypto and machine learning and satellites and, a few other things besides. And the rest of the economy is kind of thinking about the stuff that tech was obsessed with like 10 years ago, like e-commerce and delivery and logistics and TV and advertising. Nobody in Silicon Valley is obsessed with e-commerce anymore, or with TV. TV has entirely become a TV industry conversation, but it's all completely changing because of technology. So that kind of divergence is kind of interesting. And meanwhile, you have this sort of other divergence, which is that, an awful lot of what actually gets built in tech is not to do with crypto and machine learning and, quantum and all this kind of stuff. It's to do with taking ideas that were around 15 years ago and applying them to some new sector. It's doing a two-sided marketplace, but for nurses. It's a two-sided marketplace, but for oil field workers. It's a two-sided market, but for that. It's Google Docs, but for video. It's Google Docs, but for podcasts. It's Google Docs, but for recording a video interview. The product that we're using now, like, this is not cutting edge, amazing, groundbreaking science. I mean, there's a lot of good engineering in it and good people building a good product, but this is not like, no one today would say, oh my God, that's the future. I haven't seen it. If I had shown this to you 20 years ago, you'd have said, oh my fucking God, how the fuck did they do that? But now it's like, yeah, whatever. It's like 3, 4K streaming video in a Chrome window. Boring. And that's kind of the reality of an awful lot of technology is that you're taking stuff that was an amazing new idea 10 years ago and just applying it over and over again and solving problems in every other industry. The only thing I can say is to be curious and easily bored and to continually kind of try and step out of the stuff that you're paying attention to and look for a different question. I mean, this is I was talking to somebody who did a thing this morning talking about the App Store. And the funny thing about the App Store is didn't we have all these arguments 10 years ago? Why are we arguing about this again now? We did all this in 2011. In some ways, the same thing with VR. Didn't we do that? Like 5 years ago? Like, why are we still talking about that? It didn't work. Like, next question. Move on to something else. And I think that's always like the imperative is you don't want to climb out along the branch. You need to be continually looking for the next branch and looking how you climb up to the next thing.
Now, when I look at your background, what I see is you started as a history major at Cambridge, where you graduated with first class honors. I'm kind of curious, when you back then studying as a history major, is what you're doing today what you had in mind, or was that a whole different world for you at the time?
Well, so history is, to study history is to
only to a very limited extent to try and know what the facts are, because there are infinite facts. The point rather is to try and understand what it meant and what could have happened differently and why it happened the way it did and what were the sort of the fundamental trends that were driving this. And so you can apply that process to thinking about Napoleonic Wars or the Crusades, or why Britain became a dominant power in India. Or you can apply it to trying to work out, well, what does it mean to say that this is open or closed? Or what does it mean to ask, well, why would that platform work? Or why are consumers doing this rather than that? And try and work out what the underlying sort of the important operating factors are. And so it's effectively the same process. You're just looking at a different topic.
Now, in your time at Cambridge, was tech part of the coursework at the time, or is this something you kind of brought into your life after that?
Well, I was studying history. I wasn't studying computer science. But I mean, I suppose there's a general point here that technology was actually a pretty small industry until quite recently, and wasn't really an important part of most people's lives. When Netscape launched in 1994, there were maybe 75 to 100 million PCs on Earth. And now there's 4.5 to 5 billion people have a smartphone. And so technology was always, or software or computing, whatever you want to call it, was always sort of interesting and exciting. But it wasn't actually an important part of most people's lives. Whereas really, even only in the last 10 years, it's become, you might say, a systemic part of society. And it becomes something that politicians have opinions about the App Store as part of a national platform, which wasn't something that anyone was talking about in 2011. Whether the opinion is right or not is a different point. But, the simple fact that a presidential candidate talks about the App Store, it just reflects a shift in the nature and the role of technology in the last sort of 10, 15 years. So when I went up to Cambridge in 1995, I think I was the only person in my college who had a PC and knew how to use it and wasn't a Komsky. And in my third year, all the first year, so that would be 98, 97, 98, all of the first year had a PC and knew how to use it. And that was the internet, because then there was actually a reason to get one of these things. Before that, in 1990, what would you do with a PC? Well, you'd write documents with it or do spreadsheets with it and maybe play games. But games consoles were better for that. There was no real reason for a normal person to have a PC except because you wanted to have a PC. And that changed with the internet more than anything else, I think. And so that's been the transition in the last 25 years, is that tech went from being one of many industries, but to being the new central industry that shapes everything else.
And kind of feeding off of that, every year you publish a big presentation digging into the macro strategic trends in the tech industry. And this year's was called The Great Unbundling. And there's a great quote in there from Kraft Heinz's Jorge Paulo Lemann saying, "I'm a terrified dinosaur. I've been living in this cozy world of big brands, big volumes, nothing changing very much. And you could just focus on being very efficient and you'd be okay. And all of a sudden, we're being disrupted in all ways." And of course, he's referring to tech effectively enabling a whole new set of paradigms of how to sell things. And I'm curious what's your thinking on this, and how do you explain the great unbundling to our listeners?
Well, so, I think you can kind of generalize that quote to sort of $20 or $25 trillion of spending across kind of retail and e-commerce and advertising and marketing and TV, where all of the kind of traditional value chains, go-to-market partnership structures, industry structures are breaking apart. And all the cards are thrown up in the air and no one really knows where they're going to settle. So, 25% of L'Oreal sales are online, and they're not online through the kinds of channels that they're used to dealing with. A third of Europe's pay TV subscriptions have gone away in the last 5 years. Over half of all advertising globally is now on the internet, and it's driven by data rather than being driven by creative. And most of the growth in CPG in the last decade has come from new brands, even before the explosion of e-commerce. And so you have this sort of breaking apart in which it used to be you had this fairly straightforward value structure in that the Procter & Gamble would make the product and they would have an advertising campaign, and then they would ship trucks of that product to retailers, and retailers would also have advertising campaigns, and the advertisers would sell the product. And now the advertising would mostly be on TV or in print, and TV is going away, is declining rapidly, and print has kind of gone away. And those retailers now have many new kinds of retailers, and very often Procter & Gamble is competing with people who don't sell through those retailers but sell direct, or start by selling direct, or build their own brands. And the new retailers function in completely different ways, and so the way that you get something sold on Amazon is not the same as the way you get something sold in Walmart or in Sephora, or indeed in Nordstrom's. And so all of the presumptions about the way that you go to market, the way you build a brand, the way you ship a brand change. The same thing on the retail side. It used to be that, you were constrained by real estate and by the distances that people would travel, but now you have a whole other set of constraints and another set of parameters. I think in many ways, like the sort of core observation might be that, as a retailer or a marketer or a brand or an advertiser, there's sort of two fundamental purposes you're trying to serve: logistics and discovery. On the one hand, how does the customer physically get their hands on the product? And on the other, how do they know it exists? And how do you persuade them they might like it? And in the past, you had an ad budget and a marketing budget and a retail rent budget, and maybe you had a returns budget, and maybe you had a shipping budget. And now those budgets all kind of become interchangeable, because you can say, if we open a store in that city, can we decrease our Amazon budget? If we open a store, what happens to our returns? What happens to our Instagram budget? Does our Instagram ROI change? Should we shift from search advertising to free returns? And, before the internet, those were not choices open to you. You couldn't say, should we open a store in that state, or should we advertise in that state? That was not a meaningful question. Now it is a meaningful question. And so you have, as it might be, $1 trillion just in the USA of spending that all sort of becomes changeable or interchangeable. And everyone's sort of trying to work out, well, what does that mean? What would the new balances look like? How would you go to market in this environment?
Now, one of the things that plays a big role there, of course, is AI, at least in my mind. And I'm curious about your take, because with AI, you can scale up how much you personalize how you advertise to people. You can make it exactly tailored, or at least it's trending that way, to that person's personality, at least the history of their personality on the internet. And I'm very curious about your thoughts on that direction, the role of AI in this great unbundling and beyond in our everyday lives.
So, I think there's a kind of a useful sort of a joke almost in AI research that AI is anything that doesn't work yet. So as soon as it works, people say, well, that's not AI, that's voice recognition, that's pattern recognition, that's just a database. And if you go back to the 1970s, AI research, or 60s, AI research was actually just a database. People thought that they could do language translation with database lookups. You can match this word to that word, and you could translate it. And that was AI. What people called that AI then. Now you say, no, that's not AI. That's just a database, and it didn't work anyway. And so AI is anything that doesn't work yet. And it's sort of more useful, I think, to talk about specific techniques. And so the technique at the moment is now, sits underneath everything else, is machine learning. And machine learning is essentially pattern recognition. And it unlocks a class of computer science problems that we couldn't really solve before. And the general way of describing this is that there's a class of problems that are easy for people to do, but hard for people to explain to computers. And so you have problems that are hard for people to do, but easy to explain, which would be, for example, calculate 10,000 mortgages. It's quite hard to do that in your head, but it's very easy to tell a computer how to calculate 10,000 mortgages or 10,000 insurance premiums. On the other hand, there's the opposite kind of problem. Is things are very easy for us to do, but very hard for us to explain. Why? How? Like, tell the difference between a cat and a dog. Okay, it's very easy to do. Now try explaining, well, why exactly is that a cat and not a dog? Why exactly? If you remember the Plato was describing a chicken, and he said it's a featherless biped. And no, he's describing a man, and he says it's a featherless biped. And Socrates holds up a plucked chicken and says, "Here's your man." And so you have this kind of whole class of problem where you would try and do it with rules. How would you recognize a dog? Well, look for something with edges, and look for something with a texture that looks like fur, and try and make something that finds legs, and look for ears, and look for pointed ears, and look for a tail. And it would always sort of work, but it would never actually be able to tell the difference between a dog and a goat or a cat. Never mind a wolf. And the same thing with translation, the same thing with speech recognition. So there's a whole class of problem that it's very easy for you to look at a credit card transaction and say, oh, that looks weird. Much, much more difficult to actually encode why. And so machine learning turns this from a logic problem into a statistics problem. And so it turns it into a pattern problem. And that solves this kind of great class of problem that we couldn't really solve before. But it's not like a step to HAL 9000 any more than databases were a step to HAL 9000. Or if it is, it's not a very big step. It's not a step to general AI. And so the other side of this conversation is always, it's a little bit like, so say we're in 1910 and somebody looks at an airplane and says, wow, these are getting faster and faster and higher, like they might accidentally go to space. And the aircraft engineers said, well, number one, we're not quite sure if it's theoretically possible to go to space, but if it is, it won't be with a 10 horsepower engine and canvas wings. And I think where we are now with all of this is, there was a sort of great break. People tried to do machine learning in the 80s and it didn't work because we didn't have remotely enough data or enough computing power. And then in about 2012, 2013, people work out to think, oh, actually it's work now. And now we're at the stage of trying to work out, well, how do you turn that? On one axis, how far can you take this and what other kinds of problems can you turn into pattern recognition problems? And on the other side, what products can you build with that? And what real-world problems can you solve with that? Because it's not just image recognition and speech recognition, there's lots and lots of other things. And so we're now deep into sort of people building companies using this and, existing companies kind of creating new products with it or changing or making their products better with it.
Talking about building companies, I want to take a little sidetrack here actually, because I'm really curious about your time at Andreessen Horowitz. And I mean, you were a venture capitalist at one of the, some people say, the leading firm in venture capital for several years. And I mean, you must have seen many, many companies built. Probably in those days, I mean, AI wasn't as much a thing yet. This is now a few years ago, but you've seen many companies build. And I'm kind of curious, even though you're not venture investing anymore, if you were to be investing today, how would you be looking, you think, at companies that use AI, build on top of AI to build new kind of systems that you couldn't build without it? And where do you see the big opportunities?
So, well, first of all, just to be clear, I work for a VC firm. That doesn't mean I was an investor myself. I think more generally, so as I said, sort of machine learning, and as I said, I hate the term AI, which I think conceals much more than it reveals. Machine learning sort of starts working in 2012, 2013. In sort of 2014, 15, one started seeing companies that would say, well, I'm an academic, here's my CV, and give me $20 billion and I'll register a domain. And then in sort of, then the next step is you see people saying, well, I'm going to make an image recognition platform. So I'm going to build the best image recognition, and then other people can build image recognition products using my image recognition platform. And then the next step after that was, something that comes to mind is we invested in a company called People.ai, which does natural language processing on text going in and out of Salesforce to work out which of your sales pipelines is going wrong. And at that point, that's not really a machine learning company. That's a sales process optimization company that's selling enterprise software to people with large sales forces. And at that point, it's become a product. And there's always a sort of a progression with any new sort of piece of primary science, which is that it goes from science to, it goes from sort of physics, so to speak, to science. and then to becomes a technology, and then it becomes a product and companies, and then eventually it just disappears and it's inside everything and no one notices anymore. And that's sort of the progression that machine learning went through. It's, as I said, there's sort of two axes now. One is people are still doing sort of primary research on, well, what else can we do with it? And that's what you see with things like GPT-3. On the other axis, people just making companies solving some problem that you've never heard of in an industry you've never thought about that happens to use machine learning as a tool in order to solve that problem. But that's not what they sell. They don't go to a marine engine company or a mining company and say, would you like to buy some AI? That's not the product. The product solves some very specific problem within that industry.
Absolutely. I couldn't agree more. Of course, GPT-3 that you just mentioned is quite a bit different because that's a service and natural language processing service that other companies can build on top of using it as a tool. And actually, we had Ilya Sutskever, one of the minds behind GPT-2 and GPT-3 in the season finale of our previous season. And one of the things that always inspires me talking with Ilya, and where I think there's a bit of a gap between what you're thinking and what Ilya's thinking, I'm curious about your thoughts on that, is when I talk with Ilya, I get a sense that things like GPT-3, things like scaling up the systems we're currently building actually could get us really, really far. We could build, amazing AI systems 5 years from now, maybe with just scaling up the ideas from today, even without needing to make a lot of change. And that's a trend that we've seen for several years now, especially at a place like OpenAI, where they really emphasize the scale of things they work on. And in contrast, you're saying, well, it's nice to have pattern recognition, and it allows us to build so many great applications. It's influencing the world in many ways, but it's not going to get us closer to a more general AI system.
So that's pretty much what the vast majority of people kind of at the coalface of machine learning research think. And, this may be a building block, but you're not going to get HAL 9000 with more ML any more than you got it with more database or more expert system. Now, of course, it's sort of theoretically possible that if you added 1 million times more compute, then general AI might pop out the other end. But that's something that's very difficult to sort of know deterministically. And in the same way, it's sort of theoretically possible that if you just put more engines, you'll keep going higher and higher and higher, and eventually you'll get to orbit. Well, yeah, no, actually, almost everybody in this field thinks, no, you would actually need some other, we have an indeterminate amount of development to machine learning, and then there will be an indeterminate number of future breakthroughs of principle at indeterminate points in time. And at some point in the future, we may have something that you could describe as general intelligence. The challenge, of course, in that is the general intelligence. This isn't actually just a sort of a one linear axis. That, a dog has general intelligence. And, one can sort of say that a dog is on a linear axis between us and, say, a mouse or something. But an octopus clearly does appear to be about as intelligent as a dog and doesn't seem to be on the same axis. And, a hawk has a very specialized kind of general intelligence. So it's a non-general general intelligence, so to speak. And so it's sort of, there's all sorts of kind of theoretical and philosophical problems, even with the concept of general intelligence. We can sort of say that, well, we think that we have something that dogs don't have, and we can see a capability that we can work out that they can't. Of course, there's no particular reason to believe that we're at the end point of that spectrum. And there might, just as we can sort of do cognition tests on a dog or a horse and say, well, look, they can work out this, but they can't work out that. It's entirely possible that there's some alien species that we've got sort of people in a box somewhere who's doing intelligence tests and going, yeah, look, they really don't have general intelligence, do they? They can only work out this, but they can't work out that. There's no priori reason to presume that our intelligence is somehow binary, and this is it. Whether that's obviously, it's very easy theoretically to say that some alien intelligence might have an average IQ of 300, say. It's more interesting to say, well, no, there might actually be some other step change beyond what we have to some other form of cognition that we don't know anything about, just as we look at a dog or an octopus and say, well, it's got some cognition, but not our kind of cognition. So, the more the more that people kind of poke away at these questions, the harder it becomes. The more questions seem to come out. I think, what is clear just sort of empirically is most people actually working on machine learning, most people do not think that we are in any kind of predictable way close to any kind of general intelligence, whatever that might even mean.
Well, I personally definitely think that it's very unpredictable what it'll take. But I think the unpredictability part of that is that it could always be closer than you think, could be further away, but the possibly closer than you think is part of the unpredictability.
But the point is most people do not think that it's going to come from just taking what we have further. It's not more Moore's law and more data and more compute. It's some other thing that we would need to invent, and we have no idea what that is. And it might not be that other thing. It might be 2 or 3 or 5 other things arriving at indeterminate points in the next 10 years, 50 years, 500 years. We have no idea.
Yeah, I think a big part is of how you think about what it means to have more of what we have. And you kind of alluded to that, right? Because you said we'll need more breakthroughs. And one way to think of more of what we have is to say we have, 50,000 people or more, maybe around 20 to 50,000 people working on AI research. And so we have in some sense a dynamical ecosystem where there is people who are constantly trying to come up with, new ideas that are different from what we have today. And a big one, of course, breakthrough happened in 2012, as you alluded to, with ImageNet moment and neural nets really taking off. But I think among those 20 to 50,000 people, I got to imagine one of them somewhere, or a few of them together somewhere, will have some new breakthrough at some point. And if there's so many people pushing, it's very unpredictable when it'll happen. But it seems like either it's
but you can't know this. It's like saying, look at all the people who are working on steam engines. Something else will happen. Well, this is a completely unfalsifiable statement. You can't know that.
Mm-hmm. Well, it's one of those things where I think a lot of people are getting paid to do exactly that, to try to advance AI. That's actually what they're getting paid for, giving them a good amount of time to spend on it and a good amount of resources, definitely helped by all the commercialization.
Yes, but this is, forgive me, but this is what Wolfgang Pauli said was not even wrong. You can't kind of brute force your way to conceptual breakthroughs. You can't just say, well, if we double the budget, we'll get this twice as fast. We have no idea what conceptual breakthrough might be required. It's like saying, well, we've got 20,000 people working on interstellar travel. At some point, we'll get to a new interstellar space drive. Well, you can't know that. We have no idea what it would take to build that. It's like saying we've got lots and lots of people working on steam engines. At some point, somebody will make a steam engine that can power an aircraft to go into space. Well, no, it doesn't matter how many people you have working on steam engines, they're all going to go to space. You can put everybody on Earth working on steam engines. You can't just deterministically say, well, that if we double the number, then we're going to get to space twice as fast. No, you actually needed like some completely other fucking thing. And that other thing didn't come from steam engines. It came from working completely different spheres. And so you can't just say deterministically, well, with all the people working on AI, of course we're going to get general AI. No, you can't say that. I just think that's a logical fallacy.
So what do you think about non-AGI directed breakthroughs, the kind of stuff that's happening in industry? Do you see more lower hanging fruit there and things that will take off?
Well, I think we're in this sort of stage of looking at things that can be turned into pattern recognition, or in particular, interestingly, things that can be turned into image recognition. So, and that very often is just a feature or some implementation of a feature inside something else. Everything will have image recognition, but what does that mean? A while ago, I looked at a company that is doing, they're doing metrics for the ground crew at an airport. So who's done what when the plane arrives? And you would think that's basically a paperwork problem, maybe a checklist, maybe it's tablets, it's software, workflow. No, you've got a whole bunch of image sensors and they're analyzing where people are and what they've done. And those image sensors are not taking photographs or video that a person's going to look at. what you've done is turn the image sensor into a kind of a generalized universal input that's gathering, at a physical layer is gathering unstructured data, but machine learning allows you to turn the unstructured data into structured data. And so I think there's an awful lot of places in which, machine learning will optimize something or will replace some other mechanism with a new mechanism or allow you to automate something you couldn't automate before. And you'd have to be deeply embedded in that industry to know that problem exists and to know that, that's something that we could probably automate now with machine learning. And so, that they'll, in that sense, I often describe machine learning as being a bit like the new SQL. So, well, how many things are there where a relational database would be useful? Right, lots and lots and lots. And they won't all be made by Oracle, and it won't be one big relational database. It will be millions. There will just be software. And I think that's really where machine learning goes. That it's just software.
It definitely becomes a lot easier to use every year. I mean, 10 years ago with initial breakthroughs, it required very special purpose programming. These days, well, it's easy to build on top of the frameworks that Google and Facebook are providing, PyTorch, TensorFlow, and so forth. And you can even use it as an application without even building something new. The direction I'm personally really excited about, and I know you spend a lot of time on too, is logistics. Because at my company, Covariant, we build AI for robotics. So robots can help out in warehouses, e-commerce fulfillment centers, and so forth. And so you've been spending a lot of time in that space more generally, not just, looking at, how robots can help. As I'm really, really curious about your thoughts on the upcoming trends of what's possible in logistics and e-commerce in the next few years, even.
It's possible in e-commerce and logistics is a big question. So, I mean, go back to what I sort of said earlier, that, you have these sort of two fundamental objectives, logistics and discovery or experience or something. And logistics, I tend to think of as sort of a vast multidimensional scatter plot. And so that's, how far away do you need to be? How often do you need to buy it? How big is the product? What inventory do you need? Is it spoilable? How often do you buy it? And that explains why there's a convenience store 200 yards away, but IKEA is a vast store on the other side of town and not the other way around. Well, let's explain the dynamics of milk versus the algebra of a sofa table. You buy milk every week, you don't buy a table every week. And therefore, all of those those equations tell you why department stores and big box retail and convenience stores and restaurants exist. Why is a restaurant a small local place that serves 50 people and not a warehouse with 10,000 seats? Well, there's some algebra to that. And the internet basically adds a whole bunch of other possibilities to that calculation. And it makes many more things potentially be saleable through the mail. I mean, there are always things that you could buy through the mail, but the internet makes it possible to buy vastly more things through the mail. And that's sort of one piece of what's happening. But increasingly, and so part of the project of the internet that's of 25 years has been, how many things can you convert from needing experience to just needing more efficient logistics? And this is the Amazon project, is you thought you needed to try on shoes before you bought them. It turns out you don't if you have 3 returns and you could buy 3 sizes. And so the Amazon project has been sort of converting things that were not just logistics into pure logistics with ever greater efficiency. The other side is, what turns out you will buy it online, but not with Amazon's commodity purchasing model. You need some more experience and discovery and suggesting, which is what everything from Instagram to Shein are about. But the other second step to this is that the logistics delivery through the mail is not the only logistics model. And so it might be that you buy it online and you go and collect it. It might be that you buy it online and it's brought to you in a refrigerated truck at a scheduled time, as opposed to coming through the mail. It might be that if you're buying a restaurant meal, something between a third to a half of your restaurant spending is actually off-prem already, or was already off-prem before the internet. It was takeaway and delivery. And so if you use the phone that you hold in your hand to make a phone call on a circuit switch network connection and say, bring me a pizza, that isn't e-commerce. But if you use the different app on your phone to press the text that says, bring me a pizza, that's e-commerce. And that's a slightly artificial distinction. And so some of what's happening is delivery is just converting from one kind of delivery to another. But the point is you've got these kind of 3 categories of retail. You've got retail that can be parcel. You've got retail that can't be a parcel that can be delivered to you, or you go and collect it. And then you've got food, restaurants, which basically is a guy on a bike. And those are three different logistics models for physical retail. But the interesting thing, incidentally, about then there's many interesting aspects of that. So one of them is Amazon building its own logistics and shifting to same-day delivery, and delivering most of its own, doing like something like a third of all deliveries in the USA. And so does all of its own deliveries itself. Another model is the margin impact on physical retailers of doing buy online, pick up in store, because now you actually need you're paying the retail rent for an e-commerce sale as well. So it's actually lower margin than selling it directly from the warehouse and shipping from the warehouse, but maybe more appealing to the customer. And then like, well, what does your retail fleet look like if you're doing buy online, pick up in store? For restaurants, of course, you have this whole dark kitchen thing, which is that if your orders are if you shift to a model where you don't have a dining room, then you can have the restaurants in different places with different real estate costs, and the kitchen can be staffed on the basis, and you can run the kitchen on the basis that you don't have two nightly rushes. You don't have to run the kitchen around 7:30 and 9 o'clock. It's spread evenly through the day. And of course, you could have 2 or 3 different menus on the same kitchen with different brands. You could have an Italian restaurant and an Indian restaurant in the same kitchen with different brands. And so you do actually change the production's economics of restaurants, even if you haven't necessarily changed the logistics side of certainly the delivery kind of a restaurant. So there's all sorts of different ways that your kind of presumptions of what retail is start moving around.
Now, one of the things you mentioned is, when I look at your coverage on this, is that you like to categorize effectively e-commerce logistics into the way it gets delivered, like you talked about, the bike delivery, the truck, the refrigerated truck, and the postal mail, and so forth. And when I think about logistics and I look at a warehouse and what goes around in a warehouse, it's essentially only the one category that you put that in just one category of 3 categories. And that's what happens mostly in warehouses, is things that fit in boxes or little baggies and that kind of nicely get one click and get shipped to you through the mail. Even there, when I look at it, it's partially automated, but a lot of it is not automated yet. A lot of it could be much more automated. And we're seeing trends of this becoming more automated, faster, and so forth. And I'm curious, how important do you see that as part of the whole picture, the ability to make these things more efficient, the operations themselves, beyond expanding them into new regimes like restaurants and so forth?
Well, so, obviously Amazon's whole part of Amazon's mission is more efficient physical logistics. And some of that is, becomes possible because of software and to some extent robotics. Some of it is just, here's a new company that gets more aggressive about this. Should always sort of remember that Walmart, before Amazon, Walmart was a ruthlessly aggressive, mass retailer with amazingly efficient logistics. And they did that with mainframes. So, there were all these waves of new economic models that bring new efficiencies, new retailing models, new logistics models, new marketing models, new ideas of how fashion should work. You see the same thing with fast fashion, where you can sort of re-engineer your company so that you can get the product from the drawing board to the shop in 3 weeks instead of 3 months or 6 months. So there's not anything sort of fundamentally new in that as a concept. There's a wonderful book by Zola called Bonheur des Dames, which is about the creation of a department store in 1860s Paris. And, here is a sort of hero of the novel. It's a sort of 19th century Superman who invents fixed prices. And because without fixed prices, you can't advertise discounts and sales and merchandising and loss leaders. There's this wonderful sort of 2 or 3 page section where his staff are trying to explain to him that he's selling this cloth at a loss. And he just says, oh, I know, that's the idea. And he's invented loss leaders. It's like putting candy next to the checkout in the supermarket. And so, there are always these waves of innovation and creation and waves of new models of efficiency. I don't think the internet created that. You have new channels and new logistics models, and so people, work out how to optimize them.
we are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. Now, one of the other things that you talk about quite a bit in your 2021 report is how China is becoming more and more capable in AI also, next to, traditionally AI was more US and Europe. And I'm curious in your perspective on that. What role will China play in AI, and how will that affect us in the rest of the world?
So I think this is like saying, well, what will China play in databases? Who cares? They'll have lots of AI. So will everyone else. I mean, I always think it's really that simple. China has got lots of machine learning projects. And again, I would encourage you to use the term machine learning rather than AI, because let's actually talk about what technology we're using here. China has lots of machine learning projects. Some of them are doing cutting edge technology. The vast majority of them actually aren't. Chinese companies will build stuff that serves things that they want and things that the government wants and things that their customers want. And so will every other company. But I think worrying about China, saying that China will have all the AI, it's like, it's as though we were in 1980 and saying, Europe needs a Europe-wide database strategy because otherwise America will have all the databases. What does that mean?
Well, maybe
Tesco has a database, and so does Caterpillar. And so does a Chinese supermarket chain. And the Chinese supermarket's got more branches than Tesco, so they're going to have a better database. Well, not really, no. They're just going to have a database.
Well, there are some different axes maybe to this, because AI is driven, as you said, or machine learning, as you like to call it, what's currently, of course, most effective in AI. It's largely driven by compute and data, right? And the ultimate capabilities are driven by the amount of compute and data available, as well as innovation, of course. And it seems like part of what a lot of people think about is if somebody can have drastically more compute or drastically more data on a certain domain, that could really give some advantages compared to entities that don't have the same resources. And so maybe it's not so much AI then, resources would be the right word. Who has more resources to build what they want to build, which might materialize itself in better machine learning. And I'm curious about your thoughts on that.
So, I mean, I kind of come back to this point. Well, what is it that we mean when we say they've got lots of data? I mean, Tesco has lots of transaction data. If you were to take Tesco's database and give that to Volkswagen, what do they do with that? There's nothing they can do with that because Volkswagen isn't running a supermarket. In fact, if you took GM's telemetry from their cars and gave that to Volkswagen, there's also nothing Volkswagen could do with that because the cars aren't the same. And so, data is not fungible. Data is not oil. It's not all just, in many ways, there's really no such thing as data. Baidu has a lot of, Alipay has a lot of transaction data because they are, as it might be, 80% of retail consumption spending in China. They can't use that to build a better language translation system. They can't even use it to build a better credit card system in Europe because all the retailers are different and all the customers are different and the locations are different and the data doesn't generalize at all. And so very little machine learning, one of the kind of conceptual challenges in machine learning is that it doesn't generalize. It's actually, so far it's actually proven to be extremely difficult even to generalize something in a very narrow domain, like say, scanning for lung cancer. Because it turns out that the training data that you have from the GE scanner in the Berkeley hospital is sufficiently different from the Siemens scanner in the Stanford hospital that the machine learning system you trained in Stanford doesn't work in Berkeley.
That's definitely happened. Yes.
And so then one wonders, well, China's got all this data. Like, well, what data? And what do they do with that? Now, I mean, I think one can kind of, to go to a kind of a sort of geopolitical level, clearly, we're at a point in time today where
most really important strategic primary technology doesn't actually get made in China. It comes from somewhere else. The iPhone is sort of made in China, but most of what's in it is actually created somewhere else, and China doesn't have that core technology. And on a 50-year view, one should expect China to catch up in the same way that Japan caught up. And one should expect there to be Chinese technology companies that make the best X, just as there are Japanese technology companies that make the best image sensors or the best battery. There'll be Chinese companies that make the best this or that or the other thing. And they will be at parity with everybody else. But I don't think it's sensible to say, oh, well, they'll just be better at everything else, any more than America is better at any European company. For the same reason that America isn't better than any European company at making any particular piece of technology. There are American companies that are in the lead for this or that, but it's not because they're in America and they've got all the money. And, the best semiconductor equipment is made by ASML and ARM is British and so on and so on and so on. So, I don't think one can just kind of say deterministically, well, China's got 3x more people, therefore they'll have 3x better data and 3x better machine learning. I don't think it generalizes like that. I'd be very confident saying China will reach, universal technology parity in, say, 50 years' time, whatever, or whenever you pick a date. That doesn't seem like deterministically hard to expect. But I think it is deterministically hard to think that China will just be sort of better than everyone else. Just as America isn't better, doesn't have better technology than the rest of the world. America is twice the population of Japan, but, Japan has good technology companies.
Absolutely. Yeah. Now, talking about countries, one of the things you've actually talked about quite a bit, and that's I would say, at least in the machine learning AI space, kind of new, is to talk about legislation and regulation as becoming more important as we can build applications that influence everybody's lives. And that there's a real role for regulation to ensure our lives are better thanks to all this technology. Then at the same time, of course, you see things come out like the European legislation to mandate only one type of charger connection for the iPhone, right? Just USB-C and that's it. That's what needs to be there. And so I'm kind of curious how you see kind of in some sense, the need for regulation, but also then the ability to regulate correctly and how to get in the right spot in that regard.
So, the sort of general way that I tend to think about this is that every industry, every company is subject to general legislation. So everyone is subject to accounting law and health and safety law and indeed criminal law. And, if you work in an investment bank and shoot somebody, you don't get arrested by the Financial Services Authority, you get arrested by the police. Mm-hmm. But then in every industry, if you work for an oil company and you murder and you hit somebody with your car, you don't get arrested by the oil regulator.
Okay.
But then each industry, then there are some industries that are big and important, have a bunch of very specific and quite technical issues. And so those industries get their own sort of industry specific regulation. And so oil and aircraft and shipping and fishing and banking and medicine and a whole bunch of other industries, architecture. It's like if you fuck up, the building falls down. So there's like specific rules about engineering. And you're not allowed to call yourself an architect unless there's rules about who can call himself an architect. And I think technology will kind of become the same, that there will be a bunch of sort of industry specific laws because there are big important problems that aren't covered by general legislation. So that's one answer. I think the second is that if you say, okay, fine, but so we regulate cars and we regulate banks, but actually we don't. That's 50 different things. So we regulate finance, okay, but the rules on who can have a credit card have got nothing to do with how the Fed manages the money supply, which has nothing to do with insider trading law or capital adequacy law. These are different questions. The same thing, for a car, which is maybe a better analogy. We regulate cars, but the car safety is a separate problem, even from car emissions. And that's got really no overlap at all with teenage boys getting drunk and driving too fast, nor with Robert Moses demolishing the South Bronx to build a freeway. And you can go to General Motors and say, make the car safer. And you can say you're bullying your suppliers and we're going to fine you $10 billion. You can't tell them to build more light rail or to solve parking in central London, because like, that's just not that's not a mechanical engineering problem. And I think the same thing sort of applies to technology that, you know, what is Airbnb's impact on house prices in Barcelona? Well, we can have that conversation, but there ain't nothing Amazon can do about that. Should law enforcement have access to encrypted messaging? Maybe, maybe not, but don't ask Uber. So, you know, there are 20, 30, 40, 50 different sets of questions here. And you kind of have to sit and think, well, yeah, but what is that question? And what kind of problem is that? And how do we resolve that? And then, you know, the final observation would be, you know, most areas of public policy are A, complicated, and B, full of trade-offs. And when people in technology say, oh, you don't get it, that tends to come across as people sort of wanting special treatment. But what generally they're actually saying is, no, technology policy is just as complicated as education policy or transport policy or health policy. You know, these are all complicated fields of policy, and there's always lots of trade-offs, and you can't have everything that you want all at the same time. You know, you're going to have to choose which do you want. You know, do you want, you know, more employment protection or more dynamic economy? Well, like, you can't have both. You've got to pick one. And the same thing for, you know, how do you want content moderation to work? You know, is an Uber driver an employee? Like, it's a labor law question. You know, so these are all kind of complicated questions. And they're not generally questions that have easy answers. And almost none of them are questions that would get solved by splitting up Facebook, which is kind of like saying, you know, let's solve urban pollution by breaking up Ford. Well, yeah, you could break up Ford, but I'm not quite sure what problem you think that's going to solve.
Yeah, I mean, hopefully the car pollution will be solved soonish with electric cars, which is something you've also written about, the trend towards electric. And you've also commented on self-driving and capabilities there. I'm kind of curious generally in the transportation space, what gets you excited there right now? And you've recently commented on self-driving being a bit of a fully self-driving not being the perfect nomenclature for what, for example, Tesla currently offers in its version 10.
I'd say that with this is version 10 of full self-driving is absolute contradiction in terms, because if it was fully self-driving, it would be fully self-driving. The fact that you're going to do another version that's more fully self-driving is completely nonsensical. I mean, you know, got to go up to kind of a general level. I think, you know, we talked earlier about, you know, what is, you know, AI is anything that doesn't work yet. I think self-driving is actually very similar in that it's entirely possible that we will never have a car that doesn't have a steering wheel, or that it's 100 years away, to pick a number. But in the meantime, you will absolutely have a garbage truck that can follow the crew down the road at walking pace. And when you get to the end, they'll get in. You can have that now. You have a golf cart that can drive around at an industrial campus or a school or a small town. If there's no manually driven vehicles, yeah, you can have that right now. Is that full self-driving? Well, it's full self-driving there. It's full self-driving for that street. But it's not full self-driving anywhere else. It can't drive from New York to Boston to Naples without a steering wheel. So I sometimes kind of think, well, like level 5 seems to me almost a sort of a logical impossibility, because the difference between level 4 is it can drive itself most of the time, and level 5 is it can drive itself in all situations. Well, what the fuck does all situations mean? Mm-hmm. Does that mean it can drive through Kathmandu at 2 a.m. in an earthquake? Does that mean it can drive, you know, does that mean it can drive through Naples while there's a gang war going on and somebody with AK-47 runs across the street? Well, like, what does all situations mean? I always think like it is rather like, you know, that I said, you know, in some works people say, well, that's not AI. You know, we will certainly have, you know, cars that can stamp on the brakes if someone runs in front of you. That's not full self-driving. We'll have the garbage truck that can follow the crew down the road, and at the end of the road, they get in and drive it. Well, that's not full self-driving. We'll have an awful lot of stuff like that way before we have the car that actually doesn't have a steering wheel.
And so when I listen to you, I mean, you look at a lot of things from an economic lens that trends economically. Do you see a lot of value created with, you know, self-driving technology, even if it's not fully self-driving in the next few years? Because you talk about quite a few applications there, garbage trucks, golf carts. How about deliveries, for example? You know,
deliveries are interesting, because then the question is, well, who gets out of the truck and takes the parcel to your front door and rings the doorbell? So, which is, obviously you have people experimenting with these little sort of like golf cart sized trucks, or, sort of little automated robot truck things, that drive on the sidewalk. And you have people experimenting with drones to some extent. And obviously, you can imagine, like, there's somehow there's some level of density in which drone delivery would make sense. There's a big enough place that you could put the parcel, and it's like low enough density that there's room outside the house, and high enough density that you don't have to fly too far. Yeah, that might work. Maybe we'll see. But yeah, I mean, as I said, the challenge with delivery is who gets out. If there's somebody there, if you're working from home, then that works okay. But if somebody has to come and get it, then how does that work? And I think the only real answer is the sort of combination of technology and human behavior, and we're just kind of exploring to try and work out what that will look like.